Good evening from London and a very warm welcome to the Institution of Structural Engineers headquarters from wherever in the world you are joining us this evening. My name is Martin Powell. I'm the Chief Executive of the institution, and along with our President, Don McQuillan, we are very pleased to welcome you to this special evening and the presentation of the institution's most prestigious award. First presented in 1922, and with a stunning array of distinguished recipients since that time, the gold medal is awarded to an individual for exceptional and outstanding contribution to the advancement of structural engineering. And these, of course, continue to be exceptional times. Many hundreds of you are joining this live event from all around the world. For our gold medal address in 2020, as COVID lockdown continued, the auditorium here at Institution HQ was uncharacteristically quiet. The pre-address hustle, bustle, and expectant conversations were sadly missing. This year, we are able to welcome a small and distinguished invited audience of just 30 people. And on your behalf, I extend a welcome to a number of previous gold medalists, past presidents of the institution, and representatives drawn from those active in the current affairs of the institution, both nationally and regionally. Most importantly, however, we are thrilled and delighted that our 2021 gold medalist, Paul Fast, together with wife Ruth and son Tobias, have travelled to London from Vancouver, Canada, so that the address can be delivered in person at the institution's headquarters. We extend a particularly warm welcome to Paul's many friends and colleagues back home, who we know will be sending him digital smiles and nods of encouragement during the address in lieu of their physical attendance. This then sets the scene for today's event. Once we start, the evening will continue unannounced. Immediately after the address, the President will lead us through proceedings, commencing firstly with the presentation of the gold medal, and then depending on time available, Paul has kindly agreed to a short question and answer session, which will be facilitated and chaired by the President. For those watching online, please send any questions or observations in the chat box, and these will be relayed to the President, and a roving microphone will be available for those in the auditorium. The President will then draw proceedings to a close. It is now my pleasure to formally introduce and welcome Paul Fast. Paul will no doubt share with us the essential facts that we need to know from his life story to date. No need then for me to provide a potted CV by way of introduction. Suffice for me to read the citation for Paul's award, which speaks volumes and provides all the introductions we need. An institution gold medal is to be awarded to Paul Fast in recognition of his world leadership in the design of architecturally exposed structures that include unconventional use of materials, including hybrids of timber, concrete, and steel. Paul, I invite you to come to the lecture to deliver your address.
Well, thank you very much, Martin, and the entire institution, as well as the nominating committee and President McQuillan. Is indeed a very, very special honor, a very special moment, and one that's going to linger in my thoughts a long, long time. And thank you all for coming here too, that are present here today, and all those that have joined us digitally. It's my honor to be able to share a little bit about the past 40 years as a professional structural engineer. And the purpose of doing so is hopefully to inspire some of the young engineers that are listening in today too, as well as maybe reinvigorate some of us more seasoned engineers that have laid a lot of track behind us already. However, it's very humbling to receive an honor like this too. When I view the previous award winners over there on the wall to my right, it just makes it all the more special. And it's also humbling when you think about there's so many circumstances as well as people in one's life, right, that ultimately influence the trajectory of a career. And those things are often beyond our control, so it's all very humbling. But when I look back in the last 40 years, you see in the caption there the word adventure, and it's been a wild ride. It's been a real adventure, and so I want to speak to that today. If you look up the word adventure in the English dictionary, it would suggest the words boldness and exciting and sometimes risky associated with it. And that it certainly has been in the last 40 years, a lot of excitement. There's been some boldness required, and there's certainly been some risky paths we've gone. But it's been a wonderful trail to follow. There's a couple of images that remind me, or that come to my mind immediately when I think of adventure. And the first one you see here on the title page, this is actually a bridge that was constructed above some raging waters in a canyon gorge in the northern part of British Columbia by the Gitskan indigenous people about sometime in the late 19th century. When you think about it, like these logs or these tree trunks that are cantilevering in over the gorge from two sides, probably counterweighted on the back ends, and then hanging these saplings in between and connecting with vines. I don't know how many calculations they did back then to make that work, but this for me is pure structural engineering construction adventure. Imagine being the person that was at the tip of that cantilever tree trunk, having to hang those saplings in place. It's just amazing, and so that is inspirational. When you see what was done already over 100 years ago. The other one that is very inspiring is here's our good friend and engineering colleague of times past, also from the 19th century, Isambard K. Brunel. And there on the left-hand side, you see a painting of a celebration banquet that they had in the partially completed tunnel under the Thames River. And as you know, that was maybe a little bit premature because not long after, they had a breach of that tunnel. About 2 months later, there was a water breach. And young Isambard, he nearly drowned in that flood of the tunnel. Now, in today's context, you would think that would be a career stopper. But for him, like he showed his resilience and he bounced back and became just like renowned for his engineering and construction exploits. So when I think of adventure, I think of these two images right off the top. And hopefully, as I go through this presentation today, we can whet the appetites of some of the younger engineers here listening in today, as well as the us more seasoned ones, for some more adventure. Speaking of adventure, we live in the province of British Columbia, and we have like a tremendous backwoods that we can explore. And I've done a lot of that, and a lot of that's been done with my elder son, Paul. In the younger years, I took him along and pulled him in. And as he got older, he pulled me in way, way deeper than I would have ever imagined, including a 2-week trip we were just coming off of, right in the rugged Rocky Mountains in a remote valley there, remote draw between the mountains. And it just, there's unlimited surprise adventure out there. And that's the thing about adventure. You don't know what surprises await you. There's hardship that awaits you, there's surprises that await you. But and likewise in the engineering career, in my engineering career, there's also people that you have to travel that path with that draw you into adventure. Sometimes they push you away from it. But I, of course, personally like it when clients and architects draw us in. And I also like it a little bit to standing at the edge of a cliff. Some of us sort of feel more comfortable hanging way back, right? And others want to get right close to the edge of the cliff and have a good gander over the edge. And of course, the closer to the edge of the cliff you get, the more spectacular the view, right? And so, you know, we sometimes have architects that draw us the edge of a cliff, and other times, like, we pull them close to the edge and they may feel comfortable with. And of course, there's that restraining ribbon called the building code that is supposed to keep us from falling over the edge. And sometimes, of course, we take that ribbon, we just want to move it a bit further out to the edge so we get a more spectacular view. But it's sort of like that. Maybe the legs feel a bit wobblier too as you get close to the edge. But here's the one thing about adventure, last thing I want to say as an introduction, that is that if you're going to sign up for adventure, though, and I say this particularly to young engineers, you have to be committed to it. And I recall a time my son and I took a trip down the Swift River way up in the northern BC, just shy of the Yukon border. And we were just amateur canoeists, and we came to the first rapids. We knew there was rapids along the way, and we were too lazy to want to get up and portage, yet we knew this wasn't the rapids that you want to, as an amateur canoeist, paddle through. And so we did the compromise, and we said, we're going to hang on to the overhanging branches of the river, and we're just going to sort of hang on and just let ourselves be dragged along. And then, well, you know what happened, right? Before you knew it, the current yanked us in, And like we were paddling furiously, trying to avoid the rocks, the big boulders, and fortunately we made it through without drowning. But it was a good reminder to me that if you sign up for adventure, like you got to be committed to it. And this is the thing about us as professional structural engineers. Sign up for that. There's going to be risks. There'll be hardship. There's going to be great surprises and some unhappy surprises. So I want to talk a little bit about the influence of mentors, colleagues, and family to you today as a first point. Then I want to talk about making the most of the opportunities that come our way. And then thirdly, just the importance, particularly in our younger years, of developing some design vision, a direction, some deeply rooted principles that we want to abide by as a structural engineer. And finally, embracing the surprise and the hardship that are inevitable along the way. Firstly, then, influence of mentors, architects, colleagues, and family. When you imagine a boat leaving harbor on this side of the Atlantic, if you have a certain destination over there, and as a starting point, you're a few degrees off, you're ending up at a way different place on the underside of the ocean as you would if you had an accurate orientation right from the get-go. And so it's so critical who is influencing us at the outset of our career. What mentors are nudging us in what direction? Are they nudging us toward conservatism, and just the same old? Or are they nudging us toward ambitious, bold, get out there and explore type of design? It really is a big factor. And so I had the good fortune of being mentored at a young age by an engineer called Bogue Babicki. I just spent 2 years with him, but it had a profound influence on my entire career. And Bogue was a Polish immigrant engineer, established his practice in the late 1960s in Vancouver. And when I saw that he had done this West Coast transmission building, as it was called back then, this steel structure that was suspended by cables off a central concrete core with no columns or a perimeter, I said, that's the man I want to work for. Like, if he's doing stuff like that, count me in. So I signed up with Bogue, and what a privilege it was, because he made me his right-hand man on this geodesic dome structure for the 1986 World Exposition in Vancouver, as well as I was deeply involved in the design of the International Modular Pavilions, which was an ingenious design that Bogue developed as a concept, which I don't have time to get into here. But on this dome structure here, which we call the neo-geodesic dome because of the double-layer dome, Bogue, we were offered proprietary dome designs from all manner of suppliers. And what impressed me about Bogue Babicki is he said, we are designing our own custom dome. We're going to do it ourselves. And I love that attitude. And then when it came to supporting this ramp that accesses the OmniMax Theater up there in the dome portion of the building, how we're going to hang that or support that, we talked about getting some tension rods that would come off the dome shell and just support the ramp that way. And he brought in a dome expert to critique our design from down the U.S. And this dome expert looked at him and he said, "But Bogue, these sharp concentrated loads in a shell structure, that's never been done before." And Bogue just sort of looked at him and he said, "That's exactly why I want to do it." Now, that's not good enough reason that we're doing something, right? But it just showed me an attitude that influenced me for the remainder of my life. So I'm really thankful for the influence of my former boss, Bogue Babicki. Then we also, my former partner and I, Gerald Epp and I, we took a trip to Europe in 1994. And we just wanted to be inspired. There was so much interesting architectural structure that was being constructed here by the major firms. And we just cold called Lorenzo Piano's office and Norman Foster's office and Nicholas Grimshaw and Richard Rogers, all these top architects who didn't know us from Adam, of course, and just asked, can we come speak with someone there? We just want to get inspired, and can you point us to some structures that we can go see? And they were very generous with their time, actually, and we got to see them. We also visited some of the prominent engineers like Anthony Hunt, and Chris Wise was generous with his time when he was over at Arab's office. And we went to see Rudy Bergerman at Schleich Bergerman. And what an inspirational trip that was. It was so formative, yeah. And so Rudolf Bergerman said, hey, go check out the facade structure at the Munich Airport Kempinski Hotel, which is basically a two-way planar grid of steel-cabled glass facade. So there's no trussing behind there, just like 25-meter span about in two directions. And you might want to give it a shake. And he said he had designed this, they had designed this for about over 1 meter out of plane deflection. I said, what? I mean, normally L over 300 is what we go by, right? It might be like 80 to 100 millimeters. And you're doing for 1,000 millimeters plus. So we went down there to Kempinski Hotel, the airport there, and we grabbed those cables, we shook them and watched the facade oscillate. And it was just like, wow, we're just kid engineers and we're so like overwhelmed with what was happening there that it was, like I say, it was formative. And then, of course, we went and saw a couple of my art bridges with this finely detailed concrete, right? And what would a trip to Europe be without going and visiting Boberg and Centre Pompidou and all this structure just like out there outside the building envelope, right? And then, of course, these massive cast steel Gerberettes. That was our first introduction to Gerberettes, or to cast steel. And it influenced our career too, and just some of the detailing of our structures and that. And we saw these massive things, and wow, this was just it just blew us over. So we came back full of ideas, and then we had to come back to this little duck pond called Vancouver and try and find project opportunities, right? But we'll get to that right away. In any event, that was very inspirational, formative. Then architects. We need architects and clients that take us down the path of adventure. And key to that was more than anybody else in my career was an architect called Peter Busby, who cut his teeth at Norman Foster's office. And he brought some of that exposed structure idea back to the west coast of Canada. And he opened up all manner of doors for us. And this image you see here, I think we're sitting in Dubai Airport there, following a presentation of what was a wild 1 kilometer long undulating roof structure above a concourse that was joining like a bunch of exhibition halls. And we had proposed this basket weave wood design using Paralam wood. And it was crazy. And we thought we had a successful presentation. And so we were happy. A little bit of premature celebration, I have to say, because 2 weeks later, we were told that the entire design team was summarily dismissed. So disappointment is part of professional life. But nevertheless, Peter was always willing to walk to the edge of the cliff, either together or he'd pull me there or I'd pull him there. And it was just a wonderful collaboration we had over all these years. We did some of this sort of British high-tech exposed steel tension structure too. This was sort of the Western Canada version or the Canadian version of that. At an early project in the late 80s, the EPCO Aerospace Center, where the owner gave us a little bit more budget to do something that was high-techy. And then one of the most recent projects here, this visitor center for the Van Dusen Botanical Gardens, which is this curvaceous, free-form, flower petal-like building, and just geometrically very, very complex. But we came up with a way to build the entire thing with timber. Normally, you'd reserve this type of construction for boat building, but here we did it in a prefabricated timber fashion, and turned out very successful as well. And so, yeah, we've gone all sorts of design trails with Peter, and you need these people to influence you. I also had a 25-year partnership with Gerald Epp. We were brothers in arms together. We had similar design vision. We were both wired for adventure. We were both willing to accept risk, and it was a great journey together from 1989 to 2014. And then you need support staff too. And here's some of the fellows, the 4 fellows that have been with you for many, many, many years. Dwayne Palabroda, Ian Boyle, Derek Ratzliff, so the top 2 in the bottom left. And they have been headquartered in Vancouver all these years and helped execute designs and also pitch in with design ideas. It's been fantastic working with people that are with you for a long time. And the bottom right is Jochen Stahl, my partner in Germany. And what a steep road that's been to climb. Like for a North American firm, there are no other North American firms that is headquartered, I think, in North America that have actually got an office in Germany. It's just a tough environment to break into for reasons I won't go into. But Jochen has been a stalwart over there, and we've gone through thick and thin together, but now we've got really good traction. There's great projects coming in. And we've also had the joy of being able to work on the refurbishment of the iconic Mannheim grid shell, which has just been a thrill as well as a serious design challenge. And then, of course, family. I really wish that you could give out a gold medal for the spouses, because without a spouse, when you're like zoned out, like I was so often at the dinner table, it's not like just turning a switch and shutting off the design that's going through your head, right? Or the design problem that you're dealing with. And so often the rule was when I came home for dinner, if you want to get Paul's attention, you had to yank on his earlobe, because I'd be so zoned out at times. And maybe that's why my ears are larger than others. As engineers, we call that plastic deformation as opposed to just elastic, right? But in any event, I've had great family support. I got a gold medal wife, and then she's just been super, and the kids have been super as well. They're all older now, and as of October, all 9 of them will be married and establishing their own families. And my son is here today with us too, my middle son, Toby, who's stepping into our company too, and we'll see looking forward to all the thrills that are ahead of us there. And then Mom and Dad, when I was coming out of high school, I just wanted to get a job, get a quick diploma, 2-year diploma, and earn money so I could buy a car and I wouldn't have to drive Daddy's car anymore. That was all I wanted. And they sort of nudged me very wisely and said, you know, Paul, I think there's a little bit more under the hood than you're giving yourself credit for. Get a full degree, go for the full engineering degree, and don't be content with little. And that was such wise advice because I wouldn't be here if that wasn't for that little nudge that I got from them. But my mother also played another role, and she used to say, when we had some special commissions that came our way or awards that came our way, I'd, of course, share that with my parents, and they'd be thrilled about that and be very encouraging. And yet sometimes she'd say to me then, more often than not, actually, but Paul, I'm just worried that you're going to get proud, you know. And, she just sort of let enough air of my head so that that my head would still fit through the door on the way out, you know. And so we want to be thankful for all the influences, right? And I had a great family support network, and so I'm glad for that. Making the most out of opportunities. This is so important. We cut our teeth here on simple stick frame houses for many, many years, for 10 years. Just went to developers. Can we design a beam here for you? Can we design a couple of studs for you? Save you a little bit of money. And we just plied our trade in this simple sector here. There was not a whole lot of work in this small little duck pond called Vancouver in British Columbia with a population of 4 million. So this is where we started. But we dreamed big, and we dreamed someday we're going to be international and all that. And yet that's where we all started. We got started. And I love the quote, though, of Peter Rice in his book, An Engineer Imagines, which should be mandatory reading for every young engineer. Because he says there, people say to me again and again, oh, you've had such wonderful projects. Oh, my goodness, you've had so many interesting projects. How can you be so lucky? Why don't I get half or some of those projects? Why doesn't anybody else get them? Why do they always come to you? But in a way, this is the point. Although you have to have commissions, you have to make what you can out of the commissions you get. And that is so true. Like just faithfully doing good work and creative work in the small little project that you get. And then you don't know what else will eventually come your way by way of an opportunity. And I want to show you a few small examples of that here, just tiny little projects. This being the first one, a small little gymnasium project from way back in the early 90s. Architect Gregory Enriquez, he came to us with, what is essentially about a 40-foot span, 12-meter span. And he wanted to have some sort of tapered truss there that he wanted us to design. So we decided, well, maybe we could turn truss design on its head here and come up with a different way to build this truss. So what we did was we have this product called Timberstrand in North America, and you could get it in 9-inch thick, say 90 millimeters thick and about 12 meters long and 2.5 meters wide. So we decided let's cut 2 nesting tapered pieces out of that. And then once we have those 2 trusses sort of efficiently cut out of that one board, then we're going to cut some more openings in there to make it resemble a truss. And then that's what it's going to look like. And we'll put some connectors at the end, the black connectors. And we also screwed a very thin little steel plate to the underside there because it's poor in perpendicular grain tension, this particular product. And then, of course, you may ask, well, what about all that wasted wood? Well, it didn't go wasted because that was used for these beautiful bench designs in the foyer. So rather than assembling pieces for a truss, we just actually cut a truss out of a piece of wood and used the cutout pieces for something else. And so that was just a tiny little opportunity that we availed ourselves of and had a great time with it. Here's a pair of SkyTrain stations that we were commissioned to do actually in the late 1990s. And this one here I don't want to talk about because this is a bigger commission, but this was Peter Busby's vision for an inverted canoe design. There you see the inside. And of course, that was a fairly costly design, and the sister station was left with very little money. So we had to come up with something very economical on the sister station, and it was sort of like having to rob Peter to pay Paul. In this case, it was more like rob Paul, the engineer at Gilmore Station, to pay Peter Busby for his ambitious design at Brentwood Station. However, we decided let's treat this constraint as one of our friends. And so we came up with this concept, just simple steel beams that you see on the left and right-hand side there, crossing the tracks and at 5-meter spacing. And of course, you could put some metal deck across there and call it a day, right? And say, yeah, we meet the budget and it's all over and done with. But these are the small opportunities that you want to avail yourself of to maybe do something special. So what we did here was we took a piece of Timberstrand board again, 2.5 meters wide, 5 meters long. We wanted to bow it so that the water could drain off into the gutters that were in these steel beam channels. And we put some cast iron struts on the underside there, European influence again, cast steel. Put some cables underneath, and we're off the races. 64 identical panels, economy of scale, economical. And so we did something special and something that could have just been like plain metal deck going across there. The fun part actually was we also said, let's also dispense of any turnbuckles. Turnbuckles cost money, and they can be unsightly too. So what we did was we actually manufactured those boards in the upside down position, put some steel weights in the middle, put the steel struts on top of the inverter panel, draped the cables over, pulled the steel weight out, and it was all strung tight as a drum. We had a little bit of adjustment available in the piston that joined the four steel struts there in the middle. And that was sweet. And so there you see it there being weighted down, and the struts put on and the cables slung over. And there's the final product. So just making the most out of these small opportunities. I really encourage engineers, don't think that it's just the dead end road there. You can do things, particularly with the right architects at the table. Another small one was this tiny little building here, just with about a 10-meter span, and it's the Boreal Center. The architect wanted to have a gull wing roof design, sort of metaphoric reference to the bird research. And what is there for us to do? You know, you could just take a simple crank wood beam or steel beam and space it apart inside the building there, and put some wood decking across and call it a day. But we saw an opportunity, and so we decided, let's create a three-dimensional truss, a very light, delicate truss, sort of a little bit bird-like, yeah. And we did that. Instead of a heavy planar truss with thick pieces of wood and a heavy cable underneath with a big strut in the middle, we said, let's split this up, and we'll just take off-the-shelf 2x10s and 2x4s, and we'll just interlock them, screw them together, very simple. We'll string these, what we call piano wires underneath there, 4 of them, and the whole thing will be light and delicate, and there's the final result. A piece of hardwood right in the middle, so we can take the bearing stresses of the cable pinching into the wood, and a small little room, but a delightful little ambiance, with a little bit of like the bird-like lightness, yeah? And so that was a fun one. On this image here, then you can also see this little bird's nest there with a couple of eggs lying in there. And, you know, not a real bird up there on the piece of hardwood at the fulcrum. But anyways, making the most of our opportunities. The last one here, just very briefly too, a little foyer atrium structure here between 2 blocks of two educational wings, a school in Richmond, BC. And just a solid 2x4 wood deck roof. It won't span up to 9 meters, so it needs a bit of help. So we decided, let's just put some light steel struts underneath there, skinny little steel tubes at tight spacing, steel castings at the bottoms of the tubes and the tops of the tubes, fasten it to the deck and fasten it to the cables. And, you know, with the dapple light coming in there, it's just symphonic. You know, this is the joy and the adventure of structural engineering, availing yourself of the small opportunities, and they eventually lead to the big ones. And in the meantime, we're involved in projects that are like $1 billion capital value and like 3-4 million square feet, but they all get designed on one small piece of paper at the concept stage. That's where you scratch out the ideas, and you can have as much enjoyment in the small ones as in the big ones. So yeah, the developing design vision, the importance of that. It has been said, there's a proverb that says, where there is no vision, the people perish. And I'd like to suggest a corollary to that could be, where there's no vision, there's little adventure. You know, you need strong design vision, I think, as a young engineer to act as a bit of a lodestar that will guide you in a certain direction, and particularly down the path of potential adventure. And let's start with you know, one design principle, and that would be thinking outside the box. I know this is an overused, could become a trite phrase, but this has to be so deeply ingrained in us as engineers that we are not going to be content with the same old, but we're always looking, is there something new we can investigate here? Is there a new design trail to explore here? It is just so critical that that happens. And I love this example here, this little puzzle that was given to me in engineering school. And it just is so deeply etched into my engineering psyche. There's 9 dots at the top. The challenge is join all 9 dots with 4 straight lines without taking your pen off the paper. Now, you can take that home with you if you haven't seen that puzzle before, but here's the solutions. If you try the middle one there, if you stay within the imaginary boundary of those 9 dots and try and solve the puzzle that way, there'll always be a dot left over, if not 2. You've got to get down to the third set of 9 dots at the bottom there. And notice the top line going to the right. it goes outside the box, comes back through the box, and then outside the box again, and then up, and then diagonally down to the right. And that's how you solve that thing. So it just visually suggests, what has to be really deeply ingrained in our engineering psyche, thinking outside the box all the time, not being content with the same old. And we live in, excuse me just for a moment here. As engineers, we live in absolutely glorious times. Like, think about 100, 200 years ago, the materials the engineers had at their disposal back then. And now consider what we have nowadays. Concrete with all those derivatives, ductile, agility, pre-stress, post-tension, steel. You have cables, you have aluminum, you have stainless, you have castings, all manner of materials there in the steel category. And then the wood, which has just exploded in the last 20, 30, 40 years. We have glue laminated timber and cross-laminated timber and nail laminated, dowel laminated, paralam, microlam, all these products available that help us to do interesting things with structural material. Not to mention what we can do with glass at the bottom and the plastics and fiberglass and who knows what other materials are coming at us in the next 50 to 100 years. We'll be astounded. But in any event, it's a wonderful time to be a structural engineer. And the other thing I find inspirational in terms of getting outside the box is when we look into nature and see the endless creativity in the natural world. Simple leaf like this with a primary stem and then the tributary, the veins coming off of that, or the artery coming off that, and then the veins coming off of that. It's just like an incredible structure under the microscope. And then when you look at the another end of the spectrum there, the hexagonal structure of the honeycomb, or you look at the dragonfly structure here, so light and delicate, like a membrane structure with this, stiffening rib around the perimeter of it, yeah? A snail here, with this robust shell structure. I see there is a little chip there in the surface there, but we'll call that the architectural cladding. That failed. But just a whole different type of structure there too. And then you can't help but just wonder how the spider weaves its web, and the strength to weight ratio in those filaments is just phenomenal. And then, of course, the crowning jewel of the entire natural world there is a human skeleton with its just like amazing joinery. And when you think about the embellishment, the architectural embellishment of each body, and how there's like billions and billions of people on this earth, and everyone looks different, and everyone has unique DNA. I mean, you have to think that there is another design solution every time you face another typical short little span, long span. There's another way of spanning that across. And when I look at all that, I find it very inspiring, and quite frankly, I also find it very easy to believe that there is an amazing, skillful, ingenious design hand behind everything we see in the natural world. It's just awe-inspiring. Here's a couple examples of sort of, thinking outside the box. I love this one here, Trout Lake Arena, the practice facility for the 2010 Winter Olympics. And the architect, Walter Frankel, his original vision was a flat roof up on the right-hand side there, top, then a step in the roof for a clerestory to let daylight in, and then flat on the left-hand side again. And of course, and then he said, I want to have some wood in this building too. So this is a 40-meter by 80-meter grid or plan area. And typically our immediate reaction is always, we got to span the 40-meter direction, the short direction with our primary structure. That's the go-to, the fallback. Yet in this case here, we weren't going to crank a 3-4 meter deep glue lam right in the middle of the span, monstrous connections, and just a lot of wood. It just wasn't going to work. And so how can you preserve the design direction? Just shut them down. So then the other option is right down the middle of the ice there, you put a big rectangular truss that on an 80-meter span would probably be about 6 meters deep, which would be a mega truss and way too high a clerestory. And so then we came up with the idea, well, what if we make that like a lemon wedge there? We make a Virundale arch. We've got a concrete buttress wall at the Zamboni room. We've got a concrete buttress wall available at the skate sharpening room the other end. So instead of the short direction span, we're going to span something long direction, but we're going to lock it in with buttresses and make this really light, delicate Virundale truss. Have short glue lamp spans in. One goes to the top cord, the other to the bottom cord. And there's the final design, how it turned out. And it was just wonderful. And the cost consultant actually said, you know what, this is less than going flat roof structure. I said, you better check your numbers. I'm not sure it is. But the point being, because the structure got so slender at the ends, and the truss dives down to zero depth at the end too, effectively, you've saved a whole bunch of envelope costs. And that can go back into structure costs. So that was just a fun example of getting outside the box. And similar thing happened here with the folks at HME Design Architects and Daryl Condon. Now, Daryl, he was the lead architect, and he was always one that he liked to walk the edge of the cliff together too and have a gander over the edge and just see, oh, what's out there, and let's enjoy ourselves here a little bit. And so in this case here, there's two pools end to end, a leisure pool and lap pool, about 120 meters the lengthwise and then 45 meters the other way. And so the obvious solution is let's span the short direction and then put something between those major trusses. And those trusses would have been somewhere in the order of 3 meters deep. And so then Daryl sort of suggested, well, maybe what if we do span something the other direction? And, yeah, sure, count me in. Let's try it. And then he sort of had to choke when I said to him, well, he said, we sort of agreed, okay, we have to have some steel cables there, right? We have to hang the structure. We're not going to put big, deep trusses in the long direction. So we'll hang the structure. And then, of course, the obvious fallback is we'll use some cables. And then I said to Daryl, but why don't we use the wood as cables? We'll use wood cables. And he began to choke on that. And I was choking too, but I just didn't show it. And anyways, give us a week to think about it. So we went back to the office and scratched some numbers out and realized, with a mid-span support there, this could actually work. Tightly spaced glue lamps. And so there it is, all erected in about 11 days, tightly spaced double glue lamps. And we went from 3 meter structural depth down to 300 millimeter structural depth, resulting in 15-20% volumetric savings and with attendant facade savings, so envelope savings. And so you had a little bit of money there to pay for some of the buttresses that we had to build. And so in any event, just this sort of like counterintuitive thinking, right? We don't always have to go this direction. Think about that direction. Sometimes it makes sense. And the guys were pretty uneasy when they put those first glue lamps up and stepped on them and said, is this really going to work? Because, of course, a concentrated load in the middle of one glue lamp is pretty, wangy, if you like to call it that. And but once the plywood got on and the roofing was glued actually to the deck, it all turned out great. And there's the final expression, the structural architecture expression. It turned out wonderful. And Daryl and his team there and our structural engineer team, we had it was just a nice look, a spectacular view over the edge of the cliff, if you like. And so all that to say, getting outside the box it's just a really good thing to wire our thinking with. And I know there's the codes that conspire against us sometimes, particularly when I started off, the concrete code was that thin, and now it's that thick. Same for steel, same for masonry, same for wood, same for the National Building Code. And so we're so inundated with code knowledge that we have to have now, and the formulas have gotten so long and everything. It pushes against good engineering, design, and judgment sometimes too. We know we have to have it, but And the other thing is we sometimes get so absorbed, I think, with computers and with the software and the hardware and everything that they do that can do for us. But I recall the words of an eminent professor that we had. He said, get to know the computer well enough so you know what it can do, but don't get to know the computer so well that you never become a good engineer. And those were wise words. So they conspire a bit against it, but let's keep moving here. Economy of design. I know we all strive for economical design, but I love this comment here. A structural engineer, don't know who came up with this phrase. A structural engineer should be able to make with 2 blocks where the stone mason needs 3. And yet often as engineers, we're accused of using 4 blocks as opposed to 3, right? Contractors shaking his head and his fist at us saying, why do you need so much steel in here? Well, we have to ask ourselves that question. I also love this quote here. A designer knows he has achieved perfection, not when there's nothing left to add, but when there's nothing left to take away. And that has to also be deeply ingrained in our engineering mindset. What can we still take away from a design? Is there anywhere else where we can, particularly in this low carbon era, right? Can we still, minimize structure? And we have such conservative design loads. There's no reason to add another 15-20% of fat onto our designs. So we have to avoid that. One example I want to show of that is here on the right-hand side in the image. This is a tall wood house at the University of British Columbia. 17 stories of mass timber construction on a concrete podium. The challenge here was on the left-hand side, the identical building had been constructed with concrete. And in one of the first design meetings, this slide was put up and it said, guys, $192 a square foot. If you can't meet that budget, that's what that concrete building was built for, then that's not going to be a tall wood house. It's going to be a tall concrete house. And so we went through all the gyrations of, working on a whole bunch of different solutions. Including like post and beam frame was the obvious one, right? Mass timber panels on top of that, different types of mass timber panels, this direction, that direction with the spans, longer, shorter. I think something like 64 permutations. And at some point in the whole process, I sort of thought, I think we're still at the 3-block stage here. We're not down the 2-block stage. And it occurred to me then, why don't we dispense of all the beams here? Because cross-laminate timber has this wonderful characteristic that it can span in 2 directions. So why don't we just build tabletops and park them on table legs, and we'll stack these things 17 stories high, and we're off the races with something that is devoid of extra connections, extra pieces, clean and tidy for the mechanical. So that's what we did. There's the concept. Simple tabletops parked on little legs. And the problem was, in this case here, we really did have to take that ribbon that's at the edge of the cliff, the code ribbon, and we had to lift it up and put it a bit further out there because the European and the Canadian codes did not give us the required punching shear capacity at the column support points that we really needed. And so we went through a whole testing program, tested 13 panels, and more than satisfied ourselves that the punching shear capacity was significantly more than what the codes had predicted at that point in time. So there's some pioneering involved, but that's sort of this notion of somebody moving that ribbon a bit further out, right? And there you see the failure mechanism. It looks very scary on one hand, but it was a very slow and actually ductile failure mechanism. So it would always give warning well ahead of time if anything should happen. But we had more than enough capacity there. And so we're off the races with these stacked tabletops, if you like. There's the table legs going up. There's the tabletops being flown into place. And there's the final product. And very simple, very tidy, and very close to the $192 a square foot, plus the inflation values on both products that was sufficient to see the building built as a tall wood building. There you see the prefab panels, the entire structure enclosed in 9 weeks' time, 17 stories of timber construction. So yeah, economy design is important. Holistic design. What do I understand on holistic design? What I mean by that is, can structure do more than a single function? Can it do double, triple, quadruple duty in the whole design process? And can we also pull in materials in a hybrid manner to really bring together the best design possible? When I say double, triple, quadruple duty, what I mean by that is, can it do aesthetic value or a function? Can it perhaps do mechanical, electrical concealment function? Can it do acoustic work? Can it do fire protection work? All these things, thinking holistically, that's part of the road to adventure, where it's not just so limited and a narrow scope where we're just crunching numbers to make sure something is supporting the structural loads. Here's a very simple case in point. The aquatic center, again, the facade in behind there is up to 15, 60 meters high at its highest point. And we've got hollow steel tubes there. And we said, well, let's use those as mechanical ducts. So the mechanical ducts feed into those facade mullions. They're perforated on the backside. They disperse the air along the backside, along the polycarbonate facade, and prevent the condensation. Doing double duty, structural and mechanical work. Here, one of my favorite projects, the addition to the National Arts Center in Ottawa with Diamond Schmidt Architects, Don Schmidt, a wonderful architect to work with. And it was in need of a new street presence. And I won't get deep into it, but there was different roof forms here in this edition, like a triangular one, the green there, and the middle one, so a rectangular, and then purple is some weird shape, and the pink one is a hexagonal form. And how to combine all these things, we said, well, let's come up with a two-way grid structure that sort of unifies these all architecturally. And then in the end, we decided instead of going a two-way structural grid, we'd go with a one-way structural grid because we were under such time pressure to get this built that we had to go a prefabrication direction. And so we made up these rectangular panels which span in one direction. And then we pulled together, like there's some wood in there. There's these steel side plates, the triangular wood pods rest in between steel side plates that do the primary heavy lifting, if you like, the primary spanning. And so you're using two different materials to create this wonderful ceiling effect. And then the real fun started, incorporating all the mechanical, the sprinklers, the electrical, the ceiling panels, the insulation. That's where the adventure begins, the coordination. And so we walked down that path. There's the prefabricated panel, and there is the final product, the final expression, and it is just exquisite. This is furniture quality structure, and I love this one here. And I think it was good enough so that His Royal Highness Prince Charles presided over the ribbon cutting ceremony, and for the 150th nationhood anniversary of Canada, back I think in 2017 it was. So that was another example. Last one here, I want to talk about the Olympic Oval, which was really the pinnacle of experience when it comes to holistic design. And it was an arduous road to walk. and the coordination that was required to make this a purely a well-done holistic design. It was, there are lots of hurdles along the way and lots of curves, but we got there. And the intention here was, how can we, the bane of good architectural expression is massive mechanical ducts that are hanging in the space, along with sprinkler lines and conduits and all the other clutter that tends to clutter good architecture. So from the outset, we said here, we have to develop some arches that are going to be hollow and can conceal all that infrastructure. So we came up with a concept for these timber arches, principally timber arches, actually hybrid. And once again, availing ourselves of different materials to form this hollow box, this triangular box, if you like. And the point here was glulam side, or it was constructed with glulam sides, and then a steel nosing at the bottom with a knife edge that would metaphorically reference a speed seating function side. And on the top, there's a couple of wide flange beams that are braced together that keep it all together. And those wide flange beams lift off of the facade, so you can maximize your facade height at both ends. And up at the top there, you see the sprinkler lines buried and the electrical lines. So you see none of that. And the mechanical duct goes inside. And originally I asked the mechanical engineer, how much space do you need? He said, well, maybe that tube down there, that steel blade is enough there. And then the next meeting, no, it grew to, I need the whole space there inside the arch. And the next meeting, it was like, I think I need some more. And so can we move the duct right next to the outside the triangular form there? And that was about the easiest no I ever had to give in my life. Anyways, he found a way of getting enough area inside there. But there's doing mechanical concealment work too, right? Aesthetic work, mechanical concealment, hybridization. And then moving to the panels. The panels were designed as prefab elements too, using simple pine beetle infested 2x4s, assembled in a waveform. By assembling in a waveform, not only do you improve the structural stiffness and the strength of the panel, but you're also creating 40% more acoustic surface area. And so now you put acoustic liner in that hollow space behind there. Of course, you can run your sprinkler lines in there too and hide them. And you've got a panel there that's doing like multi-purpose work, right? Not just structural work, it's doing a lot of things. And that is holistic design at its best. So there you see the erection of the panels on the glulam arches, and there you see the final uncluttered expression. And that is ultimately was a pinnacle of structural collaboration with all the other disciplines and with the architect, of course, too. And the mountaintop experience in this one here was this ad here. So here you have in the bottom left, George III and Son, a steel fabricator, third generation fabricator in Vancouver, originally blacksmiths. And they were the only ones that stepped forward and put in a bid to build these arches, because you're sort of halfway between steel and wood. That's a bad place to be, actually. And the right side, you have Structural Lam, who provide the glulam beams. And together, if you like, here's the blacksmith, maybe for the first time in history, and the carpenter getting together, taking out an ad together and saying, together, two BC companies have created the longest hybrid arch ever built. Like, that was a thrill to see that happening. And so that was just, that was live adventure at its best, but no, without hardship. Finally, just briefly, I heard a very impressionable lecture when I was in university where the speaker, and I don't know what he actually did, but he just said, be willing also in your career to maybe go down some little side roads just to check things out and poke around a little bit to see if there's something to explore there too. And that always followed me. And so in our office, many years ago, I got together with an architect and we developed this cool perforated plastic whale shape with a perforated a back structure, and then the shell underneath is also solid plastic, and the mouth is perforated and hinges, and there's a dorsal fin handle and a tail fin handle, and it stores and drip dries your bath toys. Because I had little kids and they wouldn't clean up the toys out of the bathtub, and I had that task every time. So scoop it up, hang it up, it's done. So just a little bit of a side venture, where we can get some color design jollies, right, and have some fun. On the left-hand side, in 2014, we established an ideas division in our office, and the mandate was take our structural engineering knowledge and apply it in a non-building direction and see where it ends up. So we began to dabble with an earthquake game here, which consisted of wood columns, wood slabs, wood shear walls, a shaking table that randomly shakes, and a deck of cards, and whoever builds to a certain height the fastest wins the game. We're, as with all building projects, we're in value engineering on that one right now, but hopefully it'll still come. But just a fun little sideline. One of our fellows, Ian Boyle, he came up with the idea, why don't we come up with an app, and we call it the concept app, and enable architects and engineers to basically eyeball the size of a wood beam, a concrete beam, or a steel beam for any given situation, or the thickness of a concrete or wood slab. And so we developed the app there, and 35,000 downloads later, it's being used right across the world. So part of adventure, right? Going down some of these little side trails to see what's there. And we also developed a modeling tool here for timber structures where people can quickly figure out the volume of a timber structure. But the most exciting one is just in the process of happening right now. And this is our newly built office building, which we've already moved into. And on the ground floor, we're establishing what's called a concept lab. And that lab is going to have a 500 kilonewton hydraulic ram. We're going to be able to test prototypes, build prototypes, test prototypes, make connections, get our engineers on the tools so they know what it's like to drill a big long screw into a piece of wood or connect different things. And that's a whole new avenue of adventure and experimentation where we don't know where to lead. We know it's costly, but it's just part of the unknown, right, when you're traveling the path of adventure. So we know we have huge challenges ahead of us, net zero challenges 2050 for CO2 emissions. And there's all sorts of avenues that we can go down in the future for adventure. And it's there for the taking. We'll see where it all goes. Last point, embracing surprise and hardship. It's inevitable that along the path to adventure, there are hardships, and there are pleasant surprises, and there are unpleasant surprises. And I know, being in the BC wilderness, if you like, and having been a lot of remote areas there, there's some scary moments, and there can be truck breakdowns, there can be sickness. When you're in the middle of nowhere, there can be terrible weather. All manner of things can happen. And of course, our friend here, the grizzly bear, can also show up. Now, it's one thing when you have him in the spotting scope, like across the valley, like a kilometer away, although he can make it across the valley in 10 minutes. But it's another thing when you encounter him like 3-4 meters away, or when you see the fresh tracks imprinted on the muddy trail early in the morning. But this is the thing about adventure. Like, we know it's there. We know there's risk there, but it still draws you in. Like, you can't really resist it on one hand, right? And we go back again and again. Of course, we take certain measures, and we've learned to sleep with our guns in the tent instead of hanging the gun on the branch outside the tent. But nevertheless, it's just there's a certain measure of hardship that's associated, and surprise, pleasant surprise. What's at the end of the trail? I'm always amazed the new surprises the pleasant surprise that we enjoy in the midst of the wilderness. But I've had some tough experiences too along the way, and sleepless nights, countless sleepless nights, where you're just turning over things in your mind and rechecking a design. And here, this building on the left, a very nondescript building, steel building. We're just young engineers, designed that. And then one day I got a call from the owner. He says, there's a meeting in the 3rd floor, and they heard a big cracking sound, and the building shook, and we're freaked out. And I said, I'll come over, have a look right away. And of course, I'm a young engineer, just sends shivers down your spine, right? And so I went over, checked it out, wrote him, called it a comfort letter, saying, I don't think there's any issues there. We checked the design and looked to see if there's any distress, and it doesn't appear to be so. And no sooner had he received the letter, and I got another call from him. He says, Paul, I'm panicking. There's another meeting in another part of the building now. And they heard a sound like the snapping of a big branch, big thick branch, a cracking sound. And then the building shook. And I thought, oh my goodness, And so this is just some of the things we have to experience. You are all mostly structural engineers here, right? And these things happen. And as I discovered later on, some of you would probably know that, right? The bolts were designed for bearing, but because the plates were, the bolts were torqued really tightly, and so the plates clamped together in friction first. And if they're clamped in friction, the bolt isn't in complete bearing yet. They actually brought some heavy weights into the building, so then the bolt slipped into bearing in all likelihood. It's a phenomenon that's happened on other buildings too. They slip into bearing when those heavy weights come down because they're not designed for the friction bearing or the friction shear transfer. And so that's likely what happened here. But nevertheless, these are things that happen which just, I don't like them, but if you're heading on the road of adventure, or even just work in the structural engineering profession, it does happen. For the structural engineer, for the Olympic Oval here, let me just share a couple examples in closing. One big surprise that came up is, if you want to form a triangular shaped arch with a crown at the top with glue lamp, then glue lamp is manufactured in planar fashion, right? So if you spring that glue lamp off the bottom of the buttress, at the buttress, it's going out into space. In this case, it was 3.5 meters to the right and 3.5 meters to the left of the center point where you actually want to see it come together here. So you got to push those glue lamps back in, and that results in out-of-plane stresses, which complicates the analysis, of course. And how are you going to build it? So we're scratching our heads. So this is just a surprise that comes up. We thought, oh, easy, you know, triangular arch, easy to manufacture, and then all of a sudden this comes up. Well, the beautiful thing at the end is that the steel fabricator built these jigs, and when he took those long pieces of glue lamp, just under self-weight alone, they took the form of the actual arch, the way it had to be. Top one, bottom one first, and the second one. And so in this case here also, it was only one bid that submitted, and another sort of like shock was they were expecting 3 or 4 bids. And then one day I get a call from the architect, and the architect says, Paul, one of the fabricators engineers says, this building, these arches here, if they don't collapse during erection, they'll collapse right after erection. And no call from the engineer to me, nothing, you know. And so just these type of experiences, right? This is just part and parcel of being in the engineering profession. They're very unpleasant, but they do happen. In the end, everything worked out fine. We came to the erection of the arches here. On the left-hand side and the right-hand side, they first put up 25-meter pieces, and there's this big 50-meter keystone piece that gets dropped in. And so they invited the media and the politicians out for that event, and the big piece was being dropped in, and it's not somehow. Why is it taking so long to hook this thing up? Why isn't the crane, you know, taking its hook away and we're done with it? In any event, about an hour later, the media just got bored, I guess, and the politicians got bored and they drifted away, lifted the whole keystone piece out, brought it back down the ground, had to start scraping off the glue, the epoxy glue at the end joint, just setting up. And it turns out that there was an issue with the elevation of the scaffold tower. Well, it's just, you know, overnight then you're thinking, you know, this unique piece that you've designed and now it's not going to work. So anyways, it eventually, it all worked out fine. They all fit together. But then Murphy's Law kicked in big time. If something can go wrong, it will go wrong, they say, right? And in this case, it poured rain. We were supposed to do the wood erection in the summertime, and there was a delay in the foundations. And so next thing, we were in the dead of winter, and we get as much rain as you do here in London. And it was just pouring. And then these end of the arches here, we had a little drain hole. We expected all the water to go down that steel blade, the bottom of the arch, and the drain hole out there, and it just like drain out there, and we all fine. And as it turns out, that got clogged with construction debris, and those ends of those glue lamps there, the V shapes, they just got filled like bathtubs full of water, just completely soaking the wood, and you're thinking, what's going to happen when that dries out, and the checking and on and on. And then you're lying awake at night, and it's pounding rain outside, and you beg the contractor to put a pump into the end of every arch, and you think they would do it, you know. So just these type of stresses, right? This is just, operating close to the edge of the cliff, it's just, it's just part of being there. So I've been asked by architect, I've been asked by students when I give lectures on a couple of occasions, just how do you deal with the fear, and the anxiety? And it's a very good question, right? Like we all face it as structural engineers. There's these moments, and we all have to find some way of dealing with it. And I know that sometimes the thought occurs to me also, I'm lying awake at night and I think, man, there's millions of calculations that my seal is affixed to. Could there ever have been something that went wrong? Or in all those projects that I've built, which is hundreds if not thousands, what could have gone wrong? And so we have to get out from underneath that anxiety and that fear, right? And if we don't manage to cope with it, it can, of course, lead to serious physical and mental health problems. And we had a roof collapse at a shopping center in our area in Vancouver there back in the late 80s. And I was talking with an engineer, a seasoned engineer in our, he wasn't responsible for that design, not long afterwards. And he said, Paul, he says, there but for the grace of God go I. And I think what he was saying with that was he's basically saying, we are human beings, we're fallible, and things can happen. And even though there was design errors that could be attributed to the engineering design there, nevertheless, it was a very healthy statement, one that I wrote behind my ears, and it's still there. I'm always aware of it. Things can happen, and yet, how do we deal with fear? So, for some of us, how do we cope with it? It can become a point of intersection, actually, of faith and of professional responsibility. And I know that in lying awake at night often and like thinking of some of these things, or you're trying to just double check, triple check some design, or you miss something. And you're like on a treadmill and you can't get off it because you're just thinking. And I know that nighttime is for rest, right? And daytime is for working and solving problems. And you just can't get on the treadmill. And I found myself in that situation often. So as a Christian, what I've found very, very helpful is that I, for instance, turn to the well-known Psalm 23, right? The Shepherd's Psalm, they call it, which speaks of the Shepherd Jesus Christ. And it talks about the valleys, and it talks about how, we're not spared dark valleys. We're not spared trouble and difficulties. However, like in the midst of those valleys, we're promised unconditional love, and we're promised comfort, and we're promised guidance. And there's that, he will restore my soul, right? That's so wonderful in the Old English language, like he restoreth my soul. And so just focusing and appropriating the thoughts of that psalm for my life, I just find it's just wonderful, and it helps me more often than not than to just fall asleep like a content puppy dog and go back to work the next day and pick up the tools, right, and figure out what's going on. But that's just that's how I've managed to deal with it. And so even in a worst case scenario, to know that one is unconditionally loved and cared for, it is always room for comeback, always room for restoration. That's a very comforting thought for myself. So when I look back on 40 years of professional engineering practice, I mean, I could say with a psalmist too, with wholeheartedness, I can really say my cup overflows, as it says, right? My cup overflows, like with retrospective joy and thanksgiving for all the protection, all the inspiration, the design inspiration, all the calm, like, being in the midst of the tornado, there's the eye of the storm, right, where there's complete peace and calm. For calm and those type of situations. So retrospective joy as well as anticipatory joy for what lies ahead, the inspiration that lies ahead as one closes out his life journey. And not only that, but also the anticipatory joy of what lies beyond life's journey. So I love that Psalm 23, and that's been called my coping mechanism amongst many other Psalms too. In any event, where does it leave us? Adventure is great, but we shouldn't just pursue adventure for our own sake, right? It's not just about our own thrills, like, base jumpers jumping off the cliff, right? And just doing their thing for, a thrill of the moment. It's really about our clients. And I couldn't help but also add in this final quote here from Peter Rice, which is the second part of that first quote I had, where it says, gradually people come to you to buy surprise. And the thing that's nicest about it is that when people come to buy surprise, I have no idea what I'm going to give them either. I love that quote, yeah? Like, clients come to us to buy surprise. It's not about our personal adventure and getting a thrill of the process. But if we strive to bring surprise to our clients, pleasant surprise, yeah? There's some unpleasant ones along the way, but pleasant surprise is the end result. Then surely when they are pleased and they say to us, job well done, then their joy becomes our joy. And that's the ultimate objective for us as structural engineers, bring joy to our clients and embrace the hardship and the surprise along the way. So in closing, once again, thank you so very much for this special honor from the institution. It is overwhelming. I want to strive to be a worthy recipient of this honor and represent the institution really well, inspire all the young engineers, the engineering community to reach high, maybe move a little bit close to the edge of the cliff at times, and just be willing to undertake bold, risk-taking adventures, trails in their careers. So thank you very, very much. I'm most honored.
Paul, it gives me immense pleasure to hand you now your gold medal. An honor richly deserved, hugely deserved, and to offer my heartiest congratulations. Well done. And
thank you very much.
And in addition, you are the proud recipient of your certificate, which includes the citation of your award. So again, congratulations.
Thank you very, very much.
We have a short time allocated for questions and answers by Paul. The order in which we're going to do it, there have been a few questions posted online, in fact, quite a few, We're just going to take maybe one or two of those for sake of time. And Paul has kindly agreed to answer any that go on unanswered this evening, if that's okay. And then after that, we'll have opportunity maybe from the floor to take one or two questions. But just to get the ball rolling, Paul, if I could ask you one, going back to your 9 dots and the maximum of thinking outside the box, you mentioned code several times, and bearing in mind the prescriptive nature and indeed the restrictive nature of codes, can you elaborate a little bit on how you've managed to push the boundaries and kind of think outside the box despite those constraints?
Yeah, sure. Gladly, Don. And we have to. We can't take a cavalier attitude towards codes, right? They're there for the protection of the public, and we want to design safe structures. But we also know, those of us that have been practicing a long time, that there's some really conservative aspects of some parts of the code, at least as a minimum. And so what to do with those, like in the case with the punching shear capacity of those CLT panels, typically we have to go test those products in to satisfy ourselves that something's still going to work. Sometimes we can make a judgment call where we just think the code has missed something and it just doesn't align with the situation that we're facing, and you just make a judgment call without testing. But in many cases, for instance, with the testing those panels, we had to actually satisfy ourselves that this will work. And the only way to do that is to go to a physical testing program. I would say in Canada, it's a little bit easier than in Europe to go this sort of alternative solution road. You can also, under your own purview as an engineer, carry out testing if you're willing to take responsibility for the approval of that product, whatever it might be. Here's a little bit more rigorous in that there's authorities in place that I think supervise all that testing. So the procedure can be much more drawn out here, whereas we can get the answer a bit faster.
Sure, thanks. Okay. Just going to the first question by Peter, is that Dupre Lafaro? Okay, definitely, sorry. He says the timber roofs with downstand steel cables are very efficient against gravity. How do you address the wind uplift?
Yeah, that's a good question. You have to you have to have some continuity of the top core. Firstly, you can just do it with sufficient dead weight on the roof, self weight. But if you don't have that, then you have to have some other mechanism, and it can become some continuity perhaps in the top cord that can transfer some flexural stresses through that joint at the crown of the arch, so that you have some uplift capacity that way in beam behavior effectively. In the case of the Grandview Heights Aquatic Center, we had more self-weight in there because there's a very tight spacing of the wood beams there, but it really hits a sweet spot in that sense that the net uplift that was still required to be resisted, we used those arches then as mini arches in compression for the remaining wind uplift. And it was a very slender arch. There was enough uplift capacity that we could offset that last little bit of net uplift that was occurring. So there are ways to deal with it, but yes, it's a problem we have to be mindful of when we have king posted trusses or the like.
Good, thank you. James Simpson submits the next question. In your view, when do you have enough ingredients to bring everybody else outside the 9 dots? How far does your concept need to be progressed? Clearly, there is technical proof of concept, but there is a deeper conviction needed for full buy-in. Where, in your experience, is the tipping point? Good questions. Yeah,
very, very good question. Where is the tipping point for buy-in on a concept? At some point in time, early on, I've typically found that the architect and the owner and the structural engineer, they have to hang their neck out the windows jointly. The Olympic Oval, at some point in time, everybody decided, okay, fine, we're heading this direction here. It has to happen very early in the design process. If you can't get the architect on side, we found that in cases too. If you can't get the architect on side, typically he's still the conductor or she's still the conductor of the orchestra, right? And we play the second fiddle in most cases. But if you can't get the architect on side, it's probably a non-starter because you have to have that full team effort. And on some occasions, I've even warned, I said, look, if we go down this road, there's going to be some hardship, there's going to be some challenges. Are we prepared for it to really steel the resolve of the team toward driving forward right to the bitter end? And that doesn't always happen, but it has to happen very early, where particularly the architect and the owner have to be willing to progress to that point of the drop off in the cliff where you want to take them. And yeah.
Great, thanks. And just one more from the online audience, from Satish Desai. He says, was the glue lamp protected from the water vapor rising from the swimming pool? There has been a case when the warm, damp environment had an adverse effect on the glue.
Yeah, no, it's there's been sufficient testing done on the glues that we use in glue lamp that shouldn't be the case. But the key to protection of the wood is proper humidification and dehumidification in these pool environments. You can't just let them steam away. You need proper mechanical infrastructure to make sure that these things don't happen.
Okay, can I open it up to the floor? Maybe just keep us on time. Maybe just 2 comments or questions, please. Max. And if everybody's silent, I'll take it. But just one at the back then. Yeah, thank you. If you wouldn't mind introducing yourself. Please.
Hello, my name's Roger Widstill-Smith. Thank you for that fantastic talk. One of the things that struck me was that you're really uninhibited about your use of hybrid structures. You'll have steel and timber quite a lot together, when sometimes I can imagine there would have been a discussion about either somebody saying they wanted it all in steel or in timber, and you've gone to a lot of trouble to make a hybrid structure. Can you talk a little bit more about your philosophy of how you use materials and when you decide which material to use?
Yeah, good question, Roger. We sort of get a little bit into the architectural decision making when it comes to answering that question. In that, I personally find when you have an all timber structure, and sometimes even wall finishes, ceiling finishes, timber structure, it becomes a little bit oppressive, architecturally, right? It's too dominant. One material is too dominant. So to have that balance of materiality too, with some steel, adding a little bit more, filigrane expression to the overall heavier wood structure, that drives a lot of the decisions, I think. But also just in terms of efficiency, for trussing, for instance, like, wood cords and tension result in enormous connections, right? Now, I sort of say that with a bit of a swallow because, on Grandview Heights Aquatic Center there, we did have to have a couple of splices because you can't make glue lamp pieces 180 feet long. But they're very clean and tidy. But typically, they're very connection intensive when you get a tension of, wood structures. So that sort of drives things a little bit towards steel as well. So those are the 2 main thoughts I would have in answering that question. But the principal one is also just the architectural expression. Things can get too overbearing if there's too much wood in a structure. And we also say, let's not force a square peg into a round hole. That's a phrase we often use. Let's not force wood to do things. It's great in compression, right? And let's use as much in compression as possible. Compression connections, no problem, right? Tension connections,
Okay, opportunity for one final comment or question, and then we'll close the proceedings. Okay, James.
Well, thanks very much for the wonderful lecture. It's great to listen to understand a little bit more. I was wondering, and listening to that, obviously your great experience with timber for many, many years, how the narrative of the decision or discussions around the use of timber in the buildings that you're working with has shifted perhaps from architecture to that of the low embodied carbon of timber, and how that are you finding now that more of the discussion or more of the reason for using it is driving more use of timber in your buildings beyond that of architecture purely, or how are you seeing that shift for you locally with that experience and having past experience with it to a wider use of the material that perhaps wasn't used before? And how do you see that going forward? Yeah,
thanks for asking, James, and thanks for coming today. I was thinking of you when I presented those material options in the glass there, and you've just done some amazing work with glass and carbon fiber and just right on the leading edge of that stuff. But when it comes to mass timber, right now, there is a mass timber wave, if you like, that is crossing North America, particularly in the commercial sector, and it's sort of getting into the residential, multi-story residential sector as well. It is driven largely by carbon considerations and sustainability considerations. Cost-wise, we're getting close to being on par with concrete and with steel, particularly with concrete for residential. But the carbon factor the carbon emission factor is definitely driving that conversation. And so most developers are kicking the tires on mass timber. I understand more so than over here in the UK right now. So that's definitely the main driver right now. There's definitely increased interest also in expressing wooden structures. It's like that tool, if you like, or that material was missing from our toolbox for 20, 30, 40 years, right? Particularly when we experienced the British high-tech, the European high-tech movement, a lot of concrete and a lot of steel, and not glass, of course, too. But wood there's a renewed interest in just wanting to bring warm ambiance into environment. So it's not just purely sustainability conversation driven, but also just the ambiance in a building. And so many people want to begin to incorporate some wood into the building just to give it a bit of extra special character.
Excellent. Stan, I'm conscious your hand shot up at the same time as James, and he probably caught my eye because he's sitting central, but you please have the last say, would you?
It's very short, Paul. You've reminded me, talking about codes of practice, of my time as a young engineer in Arabs in the 60s. I worked for Paul Beckman, who was a brilliant, slightly acerbic Dane. And he said, you should read the codes of practice like the devil reads the Bible. It doesn't say you've got to do it, it says you should do it. So you can decide to not do it if you want to.
Yeah. Yeah.
That's how you do it.
Yeah.
And I've spent most of my time in my own office trying to get engineers to make things smaller. I don't have to worry about whether things are going to fall down. I just have to worry about them being clumsy.
Yeah.
I'm sure that's what we all have to do.
Yeah.
Push it.
Yeah, absolutely. Sage advice, Sam. Thanks.
Thank you for fielding those questions, Paul. Thank you.
Thank you.
So, like others, I've been a huge admirer over the years of your work, Paul. And I love the way, like all great designers, that nature has influenced your thinking and expressed itself in the various amazing structural forms, some of which you've shown us tonight. I love the inverted panel with the 4 cables underneath. Well done. You've worked on so many exciting and iconic, and as to use your own words, adventurous structures and projects. And you've promoted sustainable design, particularly in the use of timber, probably before others have consciously focused on the subject. So well done on that score. You've outlined this evening an amazing career, and you've given us an equally fascinating lecture, one befitting a gold medal address, I might add, and you have enthralled us all. There are over 300 in attendance, both here and online this evening, and I think that bears testimony to the esteem in which you are held worldwide. It's my great pleasure, therefore, on behalf of everybody present, whether in the auditorium this evening or online, to thank you for coming all the way from Vancouver with your dear wife and son to be with us, and to also congratulate you on being the recipient of what I always call the institution's ultimate accolade, and also to propose this vote of thanks to you. So, may I ask you all, please, whether here this evening, literally, or online, to show your appreciation for Paul in the time-honored fashion.